Okay, today we are going to talk about correlation coefficient. So you should be on day 10, page 41 of your coordinate geometry packet. Okay, so please put your name at the top. Correlation coefficient, what is that? Well, in the last lesson we saw that when we have data that's related to each other but not exactly linear, what we do is we find a line of best fit. Okay, so what happens though is that line of best fit, what we really want to talk about is how good is that line depicting the data given, okay? So is it showing what we are trying to find out about the data? So what we use is a correlation coefficient, okay? A correlation coefficient just tells you how close is your data to the line that you've created to represent this data. And that data is, that correlation coefficient is represented by the letter R. So let's just take a second to highlight, please. You can stop and highlight those pieces. Okay, the next part of this that you see here is actually in your notes on page 42 in the back. So if you want to turn over there, and you can kind of just jot some stuff down if you want, and just get an idea of what's going on here before we get into it. So what we have going on here is correlation coefficient with an R value, and they're giving you a little summary. So I'm going to give you the summary, and then we're going to go in and do the problems, okay? So when we have data like this, we're looking to see if it has a positive correlation, a negative correlation, that type of thing. So what does that mean? Positive would mean as the X values, the independent variable goes up, so does the Y value. So for instance, if you were studying for a test, the number of hours you studied versus or compared to the test grades you got. Now, is that going to be a linear relationship? No, it depends on what subject, it depends on different people maybe. So what happens is we would get a positive correlation, but it wouldn't be exactly a line. Now, you could have positive, you could have negative, or you could have no correlation. So let's just look what no correlation would look like. Okay, that no correlation there, you see the value R equals 0. Well, that's because there is zero correlation. There's nothing that relates the independent variable with the dependent variable. So basically, in our studying of tests, we would not have a zero correlation. There is a correlation between the time you study and what grade you get. Okay, so next we talk about this R equals plus or minus 1. Well, R equals 1 means a positive correlation, and it's actually linear, okay? It's a line. R equals negative 1 is also a line. So typically, we don't get a 1 or a negative 1 because we use lines of best fit when we're talking about scatter plots. But just for understanding, this is what's going on here. When you get a linear set of points, you're going to have an R value of 1 because this is the closest you can get to the straight line. And similarly, negative 1 for the negative correlation. And by the way, the positive and the negative are talking about the slope of the line. This is a positive slope, this is a negative slope. Okay, so next. Well, if I talk about scatter plots, look what my data normally looks like. Okay, so R is going to be greater than 0, but less than 1. It's not linear, but it's better than nothing, and it's moving upward in a positive direction. So if I did my line of best fit, it would look something like that, and so that's a positive correlation. It's just the dots or the points are not landing on the line. So it's not 1, but it certainly isn't 0. Okay, so let's see what happens here. Well, we have our negative correlation. So R it's less than 0, but greater than negative 1. It's not going to be negative 1 because it's not a negative line or a line with a negative slope, but our line of best fit is, and those points fit around it. Okay, so when you have a positive slope here, your R value is going to be greater than 0, but also less than 1. Okay, so there's R equals 0, that's linear. And now we have a negative slope here, but it's not a line. That's the line of best fit, but the points are not forming a line. So therefore, R is going to be greater than -1, but less than 0. So it's going to be a negative correlation, but it's going to be like a decimal, okay? Not ever getting to -1. Okay, so that's a lot of talking. That's R equals 0, remember that, and we can highlight those pieces. Okay, so what are we going to do with this? Well, the way you find the correlation coefficient is it's in the calculator. So we need to go through these steps. So you're going to turn on your correlation coefficient by doing the following steps. Step 1, go to catalog. Well, catalog is found by doing second 0. Okay, and you get catalog. We talked about that a while ago. Okay, and then what we need to do is we need to go down to the D's because we're looking for this diagnostics on. That's what turns on that correlation coefficient. So if you notice, you should have an A in there up in the corner because that's telling you that alpha is turned on. So if you just press this X to the -1, if you see there's a D up above there because we want D's. Okay, now that got us down to the D's, and now we just have to find the diagnostic on. Well, it goes in alphabetical order. There's diagnostic off, there's diagnostic on. So that's the one we want. We hit enter, and diagnostics are on. Hit enter, and we are done. Okay, so you hit enter twice. So just highlight those so you can find those directions. And second 0, write that in so that you know how to get your catalog. Okay, so now we're on to the first actual problem here. So, exercise 2. Consider the data given to the right. Graph the ordered pairs on the given grid. So go ahead and graph those points, please. Okay, mine are done, so hit pause and graph the points. Determine the equation for the line of best fit. Now wait a second. When we do this graphically, we find a line that goes through the points. And wait a second here. This is a line, though. It's actually going right through the points. Okay, so let's go through this anyway. Determine the equation for the line of best fit. Well, in this case, we're just writing the equation of the line. The line fits on the points. So I think we're going to have a B value of 2. And if I use my rise over run, I get a slope of 1/1. So I guess my equation of my line is going to be y equals mx plus b. So y equals, wait, 2x plus 1? I don't think so. Hold on. I have to fix that. Okay, so that should be y equals x plus 2. Your m value is 1/1, 1x, and your b value is 2. So now it says state the value of the correlation coefficient. Well, what you're going to do is put these points into your calculator using that list, which can be found in the stat, using stat. So we're going to hit stat, edit. We're going to edit our list. Now mine is clear. If yours happens not to be clear, arrow up. Hit clear, arrow down, go to the right, arrow up, hit clear, arrow down, and if you recall, all we're doing is we're putting the X values in for list 1 and the Y values in for list 2. So on your paper, you should be able to see them. My calculator's covering them. Okay, so put those numbers in. Okay, so if you recall, you're just putting the X's down the left column. You hit 1, I'm down to the third one already. 1 and then 3, and you can hit down. You could also hit enter, it doesn't matter. Okay, I go back up, and I'm going to put my Y values in. So it's going to be -2, 0, and then 3 and 5. Okay, now we want to go back and check them. Don't just keep going. It's -4, -2, 1, 3. Those are good. -2, 0, 3, and 5. I'm good. Okay, next thing we want to do is we want to, so hold on, let me just go through, if you want to write these steps through. Stat, edit, 1, I'm sorry, up, clear, and then you fill in lists. If you want to write these notes again, just do that. Okay, I'm going to calc. Now this is where we come in. So the second part is to hit stat, calc, and then 4. Okay, so let's remind ourselves, what does that look like? So it's stat, calc, which is arrow over, and then you're going to hit 4, because 4 has that ax plus b. You're going to hit enter. In some calculators, you're going to have to enter a couple of times. Now look what happened here. We have an R2 equals 1 and an R equals 1. R is our correlation coefficient, so our R equals 1, and that's what they're looking for there. Okay? Okay, I'm actually going to skip over to exercise 4 now, because exercise 3 does exactly the same thing, but it gives you a negative line. So your R value would be a -1 because it's still linear. So let's look at something that isn't linear. So what I want you to do is stop, graph the points. Okay, so your points should look something like this. If you notice, it's not a line. So it says determine the equation for the line of best fit, round your coefficients to the nearest hundredth. Draw a rough sketch of the line of best fit. So, okay, so we're going to hit stat again, and we're going to hit edit because we're putting new data in, and we're going to put our list in. So up, clear, down, over, up, clear, and then down. Okay, so go ahead and put your data in. Okay, so your table should look like that. You're going to hit stat, calc, so arrow over, and then 4, because you see that ax plus b, that's our mx plus b. Hit enter. Now, our a is 0.508. Nearest hundredth, that would be m equals 0.50. Oh, I think 51. 0.51. Sorry, I lost my calculator. Okay, yeah, so this right here, 0.508 would be 0.51. Now my B value is 2.593. Rounded to the nearest hundredth, we're going to use 2.59. Okay, so my equation is y equals 0.51x plus 2.59. Okay, so if you look over here, the correlation coefficient, that's the R value, not R squared. So we need to write that, what does it say, to the nearest hundredth? So it's going to be 0.87. The 3 tells the 7 to stay the same. So R equals 0.87. Okay, so now remember where we started here. Your R value will always be less than or equal to 0. And, oops, greater than or equal to 0, sorry, and less than or equal to 1. It goes from 0 to 1, okay? So now, this is 0.87. So 0.87 would fall, okay, notice I just erased that. I said something wrong, and I don't want to retape this whole thing. So, watch. It's R goes from -1 to 1, okay? So in our case, the 0.87 falls on the right side of 0, okay? So it's a positive correlation, which we can see. Positive means moving upward, and it's a 0.87, so it's not 1, it's not linear, which we can see. But 0.87, that's like close to 0.9. That's very close to 1. Therefore, it is called a strong positive correlation. And the reason why it's not equal to 1 is because it's not a line.